Welcome to my chain rule summative video, take 557 to the power of 402. Alright, so my first problem was m of x is equal to cosecant, and then in parentheses, it's 5x to the 11th plus 3x, and all that's to the power of 4 inside the parentheses. So to start every problem that I'm going to do, I'm going to say what m of x is equal to in terms of a composite function, so then I can solve easier. And what I mean by that is I said m of x is equal to f of g of h of x. And when I say that, I mean these are the functions that are affecting like the overall m of x. So my f of x that I see is this cosecant of x that's affecting everything inside. And even in this one, you can like even see the parentheses that you have like lined out here. And then my g of x is the x to the power of 4. That's right in here because this power of 4 is affecting everything inside the parentheses. And then my h of x is just everything that's inside right here, because it has the x's, it's just inside, it's just there, it's inside. So then in order to use the chain rule, I have to find the derivative of each of these like functions, like the f of x, the g of x, the h of x. So I have to define them just like I just did. So my first one is f of x, which is the cosecant of x. So f of x is equal to cosecant of x, and I turned it into sine and cosine. So cosecant of x is equal to 1 over sine x. I know that for my trig identities. And then I know I could have used like a derivative like trig identity. And I don't remember which one it is, but there's one out there. But I decided to actually just solve for it in terms of the derivative in terms of sine and cosine by using the quotient rule, which was probably stupid, but I did it anyways. So I used the quotient rule to solve for the derivative of f of x. And here, n of x is the numerator, which is equal to 1, and d of x is the denominator, just because that makes sense to me. So I used the quotient rule, which we've gone over 100 times, and I ended up with the derivative of 1 over sine x is equal to negative cosine x over sine squared x. If you want to look at my math, it's there, but I don't think we need to go over the quotient rule right now. So then once I had the derivative of f of x, I went to h of x. I don't know why I went to h of x, but I did. So h of x is the one that's all the way inside. It's it's 5x to the 11th plus 3x. Then I use the power rule to just get 55x to the power of 10 plus 3. And then for h of x, it's just this, like this inside here to the power of 4. So it's x to the power of 4, and then I use the power rule to get 4x to the power of 3. Then once I have all of that like solved for, like all of these here, I'm going to use this like advanced chain rule that I kind of made based on my findings from the problem set. And I'm not going to say this right, but I have it written right. So my chain rule that I'm going to use is f prime x g of h of x times g prime h of x times h prime x. And that's going to be the derivative of m of x. That's going to be my whole answer. So it's going to be super long, but it's going to work. So first I need to use the derivative of f of x, which is right here. It's that negative cosine x over sine squared x. And then every time I have x, I'm going to plug in g of h of x, which is actually what's in this original equation right here. So I just plug this because if you see, like, there's g of h of x in here. So, like, it's not a derivative. So I just plug that original g of h of x inside where the f prime has x. So there's two x's because it's cosine x and then it's sine squared x. Well, it's negative cosine x. So I plug that in, and that's my first term. Super ugly. And then I have my g prime h of x. So my g prime x is 4x to the power of 3, and then my h of x is 5x to the 11th plus 3x. So I put the 4 on the outside, then I put the h of x inside, and I put the 3 there. You get the gist. And then I'm just going to do h prime x, which is just this term right here. So then I put it over here. It's being multiplied all of these three terms being multiplied together, right here, 1, 2, 3, that is my derivative. Now the next steps are me simplifying it here, and here's my answer. So this, like, there's problems in that, that's that, but this is my derivative technically. So what I did to simplify first is with this term, my g prime h of x, is I turned it into whatever by distributing my 4 to the 5 and my 4 to the 3. And you'll see later that makes it 20x to the 11th and 12x to 12x. And then I'm going to put these terms over 1 because I have a fraction here, and I want to put them on the numerator because I want to make them all one term because I can. So that's what I did. I put them over 1, and then I multiplied, and I ended up putting the cosine on the end, like the negative cosine stuff, because you always said to put, like, I don't want to get it confused with the stuff that's inside the term, because that's the stuff that cosine is, like, taking the cosine of, not cosines being multiplied by, and this is being multiplied, like multiplied, it's different things. So I put that on the outside, and I put the negative in front of everything instead of just attaching it to the cosine. So I got negative 20x to the power of 11 plus 12x to the power of 3, like all to the power of 3, and then times 55x to the power of 10 plus 3 times cosine, in parentheses, 5x to the power of 11 plus 3x to the power of 4, in parentheses, and then that's all negative. I don't know if I said that. That's all over sine squared, and then in parentheses, 5x to the power of 11 plus 3x to the power of 4, in parentheses. And that's my derivative. If that's wrong, sorry, my bad.